Okay, imagine you're running a 100-meter race at the athletics carnival or something, and you figure your time is kind of slow. So you train really hard for the following year, and you manage to run twice as fast in comparison to your first run. And what we want to think about here is the relationship between your time for the race and your speed. And so if we play the two runs again, remember we're imagining a situation where we manage to double our speed. And what we find is that by the time we finish the race at this speed, the previous run would only be halfway there, meaning the time we take to complete the race would halve as well. Now, a way to mathematically write such a relationship is to write an equation where time equals some fraction with speed on the bottom and some fixed number in that blank space upstairs. The important thing being that for each story or each question, that yellow box number is some fixed constant number. And so we can see how such an equation does the job. If we were to double the speed, we would times it by 2. And because that's happening downstairs, it would be equivalent to multiplying the left side, the time, by half. Okay, and so before we move on from this story, I just want to point out that neither time nor speed here can sensibly equal 0. Down in the equation, you can algebraically see it just from the fact that you can't divide by 0. But also physically, no matter how fast you go, you never teleport to the finish line in 0 time, right? It's impossible no matter how fast you can run. And the other extreme, if you refuse to move, so you have 0 speed, then it's impossible to complete the race in any time. So in general, whenever we have this type of relationship between two variables, we say they are inversely proportional. And so as we've seen, as one of them goes up, the other must go down. Like how, if I can run faster, then my time must decrease. But it does so in some proportional sense. So say if I can run 5 times as fast, then my time goes 5 times as small. It divides by 5. And it would be the same for any other number, not just 5. We also made a point that neither of them could be 0 because it wouldn't make sense. And now you probably shouldn't try to memorize these facts. The reason we started with the speed and time story was because it's often a helpful one to bring to mind whenever you encounter inverse proportion. If you just connect it straight away with the speed and time story, then both of these facts and anything else you might need should become quite obvious. And a quick note for calculation purposes, if you can work out what that yellow box number is, you can pretty much do anything because it gives you a formula that will work for the remainder of the question, whatever you could be asked. So let's see an example of how that works. We have a warehouse being cleaned and the time taken to clean it varies inversely with the number of cleaners on the job. And that is enough for us to write the equation t equals some number over n, where t is time taken and n is the number of cleaners. And that yellow box, remember, is some constant number. Part A is to figure out this formula, which really means to find that number, that fixed number that lives in the yellow box. So to do that, we write the equation again, but this time we put in the given values that we know, which is that it takes 8 cleaners 60 hours to clean the warehouse. So we put in those numbers 60 into the t and 8 into the n. Multiplying both sides by 8 gives us 480 as the yellow box number. And remember, the point is that this gives us the formula that can be used for the remainder of this whole story. We can rewrite the original equation and just put in 480 in place of that yellow box number. So for part B, we're looking for the number of hours it would take for 10 cleaners to do the job, meaning what is t when n equals 10? And so we can write the equation we just worked out, but instead of n, we put the 10 we're given. And this gives us 48 hours. So that's inverse proportion. Thanks for watching. See you later.